Welcome to Embedded. I am Elecia White alongside Christopher White. Our guest this week is Mark Smith, and we're going to talk about Halibut, satellites, amateur radio, and ham.
Hi, Mark. Thanks for joining the show and agreeing to tell me how to do everything I want to do.
Thank you for having me on. It's great to chat with you guys.
Could you tell us about yourself as if we met at a brunch after a nice visit at the electronics swap meet?
I've had many of those brunches. My name is Mark Smith. I often go by the name Smitty or SmittyHalibut. Halibut's been my brand since I was a young kid. Started a BBS back in the late 80s called the Halibut BBS, and it's just been unique, and so I stick with it. I'm a ham radio operator. I was in IT doing network engineering and system administration for 25, 30 years. And recently left that and have started my own company called Halibut Electronics, making amateur radio and audiophile electronics.
Which we will be asking you more about. But first we have Lightning Round, where we ask you short questions and we want short answers. And because Nick, the exploding lemur, gave us a few extra questions, we're going to have to go through this pretty fast. Are you ready?
Am I ready for Lightning Round? Yes.
FT8 or JT65?
FT8.
Linear or circular polarization?
Circular.
Tube or transistor?
Depends on the context. I'm going to go with tube because I like music.
CLI or GUI?
Again, depends on context, but most of the time CLI.
How many clocks do you own?
Do I need time? Do I have the time to count them?
Order of magnitude.
More than 10 in this room.
DEF CON or Hamvention?
Ooh. I've been to DEF CON way more often than I've been to Hamvention. I'm going to go with DEF CON. I think the parties are better.
Linear or circular polarization?
I already said that one.
Linear or circular polarization? Okay.
Circular. Linear. Wait, no, I said circular last time. Linear this time.
I'm going to cancel that. Would you ever order a spicy chicken sandwich, quote, particularly hot?
Only when Josh and Nick are around, and I would make sure that the chef heard it so that we can hear a few minutes later someone come from the back room. That can be arranged.
All right.
It's an inside story.
Do you have a piece of origami that you particularly like?
Yes, a very nice person gave it to me while I was driving north on Highway 1 through California just a few months ago. Weeks ago, however long ago it was. It's in a jar. I think it's an animal of some kind, or a wave. I think it was a wave.
What is your favorite fictional robot?
Favorite fictional... Oh, Chopper, obviously.
From Rebels.
From Star Wars Rebels.
Do you have a tip everyone should know?
Do I have a tip everyone should know? Move the decimal place one spot to the left and then double it.
Okay.
Decibels?
Decimal. How do you tip?
Oh.
I just tipped 20%. Move the decimal place one place to the left and then double it. And that's your tip.
Tip everyone should know.
Yeah.
Wow. All right.
That also works for estimates?
Yes.
Yeah, true.
Budgets?
20%.
Okay. So while I'm looking forward to talking to you about what you do professionally, we have tricked you into being on this show because Chris's dad in Connecticut wants to talk to Christopher via code without them spending a lot of money, via ham radio code.
Mm-hmm. Morse code, I assume.
No, I'm gonna hand modulate FT8.
Okay, that sounds good.
I'm thinking
By
Morse code.
Wiggling the antenna.
Because Chris has been trying to learn Morse code, which he said it would be super easy. And I said,
no, I didn't. When did I say that?
You said no. There's this method, and once you learn one, you'll never forget it.
Yeah,
and
I have 3 letters.
Right. No, right.
At 20 words per minute. 3 at 20.
Yeah.
So, and they're not SONS. I've got those are bonuses.
K, M, and I can't remember what the third letter is. What is R? Yeah, K, M, and R.
Yeah.
Someone's using the cock method.
That's it, yes.
Okay, so how can
K-O-C-H,
Christopher...
by the way, just so we're clear.
How can
Sorry, go on.
Christopher and his dad talk to each other over ham radio? What does that even mean?
Now, both of us are licensed. Both of us have done 2-meter stuff for years.
Okay.
Not between,
But not a lot.
But
Neither one of you are deeply involved in the community.
He did some HF stuff back in the 80s and 90s. He did code and some, I think he did some voice stuff, but I can't remember. But he had a whole big rig and antenna and stuff at our old house when we used to live in Southern California. But he doesn't have any of that stuff anymore. Or if he does, it's got to be reassembled. And I've never done any HF stuff except for a little bit of whisper stuff with a small kit. So I don't really understand a lot of the words that fly around. I don't really understand antennas. I don't like them. I find everything about them confusing. I have the ARL antenna guide and all of that, but I read that and it's like water down a Rain-X windshield.
Don't you have a physics degree?
Yeah, I did, but...
And you have more than a technician license.
The physics of it is not helpful.
What kind of license do you have?
I have a general license.
You're right. Okay.
Well, that's good because you need that to do HF. Does your dad also have a general or extra?
He has a grandfathered technician from the 80s, which gives him a lot of privileges.
Tech Plus. Okay.
Yes.
Yeah.
Tech with code or whatever it was.
Yeah, Tech. Yeah, that's the Tech Plus. Okay. All right. So that limits his ability, but you're talking about Morse code, so that opens it back up again. Okay, cool. Got it. So we have just touched on a whole lot of stuff that I don't know whether you want me to explain what it means, because are you assuming that your listeners to the show understand what the heck we just said in the last minute, or?
Well, the truth about this show is the listeners don't have a say in anything.
Okay. Fair.
You only have to amuse us. We don't worry too much about the listeners.
Very good then. So you're not going to be okay. Well, actually, that's not true. I was going to say you're not going to be talking from California to Connecticut on 2 meters.
Not without a lot of repeaters.
well, repeaters or the internet.
Yeah, and
there's a lot of internet linking of repeaters and hotspots and whatnot these days. So
that's fake.
Couldn't you just send email?
You can.
I could just call him on the phone too, but the goal is the project. The goal is to both be working on something together, and have this thing,
So we're going to ignore the 2 meter options, the VHF, UHF options, and we're going to talk about direct communications without infrastructure other than the ionosphere between California and Connecticut.
Yes.
Okay.
Yes.
So in that regard, you are talking about HF. HF meaning high frequency, which is weirdly named because it's actually some of the lower frequencies we deal with. High frequency versus very high frequency, VHF, or ultra high frequency, which is UHF. So HF is actually the UHF. Yeah, it was great. Fun fact: he went to the same college I did. He went to Cal Poly San Luis Obispo. Yeah. He got his architecture degree there.
Why are there so many hams at SLO?
From Cal Poly?
Yeah.
Because Cal Poly has W6BHZ, one of the best college clubs in the world, in my opinion. Not so humble opinion. I was a member of BHZ from 93 to 99. I know lots of people that were members before that have gone on to do great things, and many that have come after that have gone on to do great things. It's been an active club. I think it's one of the oldest continuously running amateur radio clubs in the country. I think it was founded in 1949, 48, 49, somewhere around there, right after World War II, right after hams got our permissions back after the end of World War II. The Cal Poly Amateur Radio Club was formed, and it's just got a long history, and it's a great club. See, in fact, I just presented there this past Thursday.
I was a member of the Ham Radio Club at Mud.
Which
consisted of me, a guy named Andrew Ross, who was a friend of mine, and the staff advisor person who I don't remember.
Who's legally required to be there?
Yeah. So there was a
staff advisor.
He was a guy who worked in the IT in the regular IT department, not the computer science department.
The poor schmuck that you looked up on QRZ found out how to call sign and said, "Hey, you work here."
So and I didn't have a license at that point, and then did not get one while I was in the club. So that's how good the club was.
It was a drinking club with a radio problem?
No, we wandered around the roof of the library, so I'm looking at antennas. I think.
Yeah, fair enough. I've done a fair bit of walking around on roofs.
Anyway, we're very off topic.
So you're going to be talking about HF, and HF means somewhere between 3 and 30 megahertz is the frequency range that is defined by the words HF. HF frequencies are the kind that can go up from your antenna. They hit the edge of the atmosphere in an area called the ionosphere, so-called because the sun's rays come in and ionize all of the atoms up there and make it electrically reactive. And it actually refracts that radio wave back down into the earth again. And in this way, you can do what's called skip. And so your radio waves kind of go out horizontally. The earth goes out from underneath it. It goes out, it hits the ionosphere, and then comes back down to the earth somewhere thousands of miles away. And this is one of the primary modes of propagation in the HF bands. And
you said somewhere, and that's kind of important because you can predict where, but not entirely.
Correct. The ionosphere changes all the time. The ionosphere changes based on the time of day because it's being ionized by the sun, and the sun is not constant in our sky. And even then, there are other things that will affect the ionization in the upper atmosphere, like solar storms, right? Like if we've got a big solar storm that's coming, it'll change it. I don't know whether it makes it bigger or smaller or moves it or whatever it does, but it changes, and it's moving all over the place. And so the problem with HF communication is that it is not always predictable. You can't say, I will always have a path from X to Y. But you will almost certainly have a path to somewhere. And so if you are trying to talk to a very specific person, you're going to kind of have to keep an eye on when the paths open to that particular location. But if you're just trying to get on the air and talk to somebody, yes. There will be somebody.
Yes.
Yeah.
Okay. And you mentioned the sun. What is that exactly?
The sun is this. They keep saying that fusion is about 20 years away. Then that's totally lies because nuclear fusion has been going on since almost the beginning of time. And we've had nuclear fusion in our planet for about the last 4.5 billion years, if I remember correctly.
I don't believe it. I've never seen it.
Yeah.
I don't believe it exists.
You must have very pasty skin.
The weather's been particularly bad here for a few weeks.
Well, yeah, that's true.
For you too, I think.
Yeah, not as bad as you guys. We're not on a south-facing hill. It was raining pretty hard this morning, but it looks like it's dried or stopped raining. It hasn't dried up, but it's at least stopped raining right now.
So time of day affects the ability to talk through the refract through the ionosphere.
Correct.
Does weather?
Not generally. Some aspects of weather can affect your noise floor. Like if there's a lot of lightning going on, that creates a lot of electromagnetic interference, and that will sound like a crash. They call it lightning crashes in your receiver. And it just creates noise, and it makes it harder to hear weak signals. And it doesn't even have to be lightning nearby. Lightning crash noise will travel thousands of miles. And that's called it's ground wave propagation, where it actually travels along the surface of the Earth. It doesn't necessarily bounce off the ionosphere. But that's about the only thing I can think of. Like rainy versus sunny, I don't think is going to affect, because that's all low altitude stuff. The ionosphere is, tens of thousands of feet up, hundreds of thousands of feet up.
And you were talking about UHF and VHF, the higher frequencies than HF. What am I looking at, like a 40-meter antenna to put somewhere, or?
Well, we're going to get an antenna.
I mean, you mentioned 2 meter. 2 meter is
VHF. Yeah. So the meters that we're talking about here are the wavelengths. So the actual length of the electromagnetic wave as it travels through the medium, air in our case.
Which is inversely proportional to
the frequency.
Correct.
Frequency in hertz and waves in meters.
And the speed of light. You got to throw a speed of light in there.
Yep. And there's a C in there somewhere.
Oh, right.
And
I always forget about that.
Yep.
This is like a 3, and then you ignore the rest of
It's a constant. You just normalize everything.
Yeah, 3 in 100 million, and that's all you have to remember. Yeah. But basically, as the frequency goes up, your wavelength goes down. As your wavelength goes up, your frequency goes down. So that's kind of and by the same proportion. So, 100 megahertz is about 3 meters long. 200 megahertz, twice the frequency, is about 1.5 meters long, half the wavelength. So it goes up and down by the same amount. Okay, you were asking about VHF and UHF, and do you need a 40-meter antenna and all that stuff? So the 40 meters on a 40-meter antenna is not how big the antenna is. It
can be.
Well,
I've seen these guys.
So a 40-meter long antenna would be used to receive the 80-meter band, because typically you are putting up what's called a half-wave dipole. That's kind of the basic element of any antenna. And a half-wave dipole is, as the name makes it sound, a half wavelength long. And so if you're trying to receive or transmit on the 80-meter band, your antenna is roughly 40 meters long. Similarly, if you've got a 2-meter radio, actually, once you get into VHF and UHF, you're not typically doing dipoles. You do what's called a ground plane, which is only a quarter of a wavelength long. So at 2 meters, your antenna is about 50 centimeters long, which ends up being about 19 inches.
Okay, so we were talking about the frequency Christopher needs, HF.
Yes. So,
and you gave a range for that, but I've already forgotten it.
Yeah, so HF is, by definition, the term HF refers to any frequency between 3 and 30 megahertz. As amateur radio operators, we are only allowed certain little slivers of that band between 3 and 30 megahertz. So like let's do this. HF is 3 to 30 megahertz. VHF is 30 to 300. UHF is 300 to 3000, so on and so forth, right? So each of those kind of very wide spectrums or swaths of spectrum is a decade wide, times 10 in frequency or divide 10 in wavelength. Right. So HF is 3 to 30 megahertz wide. We hams only get little slivers inside there. And even then, depending on your class of license. So we mentioned earlier that Christopher has a general class license and that your dad has a technician plus license or a grandfathered technician license from the 80s when he actually had to pass a Morse code test to get his license. So those classes of license also dictate on what frequencies you are allowed to transmit. These rules only apply to transmit. You are allowed to receive.
Sure. Well, how are they going to stop you?
Well, no, don't take that for granted, because a lot of countries that's not true.
Oh, yeah, true.
Like if you go to the UK, they do have restrictions on receiving signals.
Right, TV.
Now, TV licenses and stuff like that. I mean, that the amateur bands anyone's allowed to receive. The rules are explicit about that, but you're not allowed to receive certain, it's a allow list, not a deny list, right? So these are the frequencies you are allowed to list, or you're allowed to receive. Everything else you are not allowed to receive, which is completely foreign to me, because here in the U.S. it is a deny list. You're allowed to receive everything except for these few swaths that have exclusions for like cellular and I think land cordless phones. I think that exception may have been removed, but you used to not be allowed to receive cordless phones, that kind of stuff. But anyway, so your license class dictates what frequencies you're allowed. As a general, you have privileges in every ham band on the HF, in the HF section. You don't have all of the ham bands in the HF section, as in you have at least a little bit in every single band, but you don't have the entire band.
Sure.
Your dad, as a Tech Plus, has much more restricted permissions. He is not allowed to do voice on any band except 10 meters, which is roughly 28 to 29 megahertz. So there's only a small section of voice that he's allowed to do up near the very top of the HF band. And the 10-meter band is not always open. We're actually at a pretty good time right now of the sunspot cycle for 10 meters. 10 meters is pretty open right now, and it will be for the next 5 years or so. But the other half of the sunspot cycle, 10 meters, is closed. It never opens up. You can do local communications, and that's it. There's no at no point does it ever skip off the ionosphere.
Okay, so we're saying they should use 10 meters because they both can.
He may,
and they want to do it in the next 5 years.
He may upgrade his license, so let's not get too worried about the tech.
I still want to go back to how much of an antenna are you going to need, and how much your mother and I need to discuss this.
So if let's assume he has not upgraded yet, the only band, the best band for him would probably be the 40-meter band, which ends up with an antenna about 65 feet long, which is what Elecia is really trying to get to.
Okay.
Yeah.
But let me just boil it all down. You have a 65-foot section of wire with a feed point in the middle of it. So you got to run the coax up to the middle of the 65-foot section of wire.
Yeah. Okay, Mark. But tell me about the end-fed half-wave antenna.
The end-fed half. Okay, so I just said you had to run the feed line up to the middle of that. That is for a half-wave dipole.
Yeah. Dipole,
meaning two poles. So I've got a quarter wave on one side and a quarter wave on the other. That is kind of the basic element of a antenna. That's what resonates, right? Think of a guitar string. You're a musician. Think of a guitar string. A guitar string, when you pluck it, it resonates half of a full wavelength, right? Like the entire thing. We're not talking about harmonics. Don't worry about 12th fret harmonics, because that's a whole different thing. But if you just pluck the string, the whole thing moves up and down, and it looks like half of a sine wave, right?
Sure.
That's exactly what you're doing electrically with the wire that's up in the sky.
It's 65 feet long.
65-foot long wire, because
just
that
getting
is...
hung up on this. It doesn't have to be straight into the sky.
It's not tall. This is horizontal.
Yeah, I can just string it down the backyard.
Well, yeah. Now, the higher you can get it, the better. But if you can only get it 10 feet high, then you can get it 10 feet high, and you can make it work. If you could get it higher than that, it would work a little bit better. But it doesn't mean that it won't work when it's relatively low to the ground.
And so it has to be a half wavelength. You can't get by with. I've read about end-fed half waves, and I've seen people do things. Oh, I have random wire length, and I just tune it, or I have a quarter wave, and it works okay. And so, what is that? What does that actually mean? Like, does it mean like the efficiency's way down, and it's not going to reach as far, or I'm going to knock out my neighbor's microwave?
Well, you may do that anyway, but that's a different issue. We'll talk about that later if you want. The basic element of an antenna is a half wave because it resonates, right? Now, there are things that you can do to make that resonate differently. One of the things you can do is you can change the feed point, right? Like the feed point is basically where your guitar pick hits the string. Where are you exciting it? And you know how the tone of a string is different when you pluck it in the center versus when you pluck it close to the bridge?
Sure.
That is... Roughly speaking, the analogy is straining here. That is roughly the impedance of the antenna.
Okay. All right.
So when you feed your half wave antenna in the center, the impedance is closest to 50 ohms. It ends up being closer to like 72 ohms. And all of the coax that we use is either 50 or 75 ohms. So it's a really good to feed it in the center because that is kind of like the natural way all of this wants to work.
I see.
You can then move that feed point from the center and do, let's say, roughly 1/3 on one side and 2/3 on the other side of your total half wavelength. That's what's called an off-center fed dipole. It works roughly the same, but the impedance changes. I think in that case, the impedance goes up to about 200 ohms, 300. I might be misremembering that, so don't quote me on it. But it means that you have to put a little device at the feed point that transforms the impedance from your 50 ohm coax to the roughly 200 ohms of the feed point. But by doing that, it now can resonate on different frequencies, kind of like a harmonic on a guitar string. For non-musicians, if you pluck a string, the whole thing moves up and down. If you put your finger halfway along the string, which is the 12th fret, and then you pluck the string, it makes a node right at the middle of that string. And so now each half of the string is resonating opposite of each other, and it makes a tone that is 1 octave higher because it is now twice the frequency. The wavelengths are half as long. You can kind of start doing the same thing with the feed point of your antenna. And then if you move the feed point all the way to the end, the impedance gets super high, and you can kind of like fake it with a lot of things. And you end up needing an antenna tuner, or it's a matching network, and you can do some magical things there.
Okay.
The problem with this is that it ends up having a very difficult to predict radiation pattern. If you stick it up in the air, you will radiate. There will be somebody somewhere that can hear you. It is very difficult to say, I know exactly where this is going to go when I put it up.
Oh, all right.
You can put it up and say, hey, who's hearing me? And then figure it out after the fact. But it's difficult to design a system and say, I know I want to talk to this person, and that they're here, and therefore I orient the antenna this way. It gets much more complicated. You have like weird lobes and nulls in your radiation pattern.
Going back to the guitar example, that would be like plucking the string at one end or the other, and then using something else to actually make it.
Not sure the analogy holds up.
Well,
in that extreme.
I mean, at that point, you're just kind of like hearing a click, maybe.
Well, so if you pluck the string right next to the bridge, you end up with a lot of higher frequency harmonics in the resonance of the string. And that kind of happens with an antenna too. It allows you to radiate. Let's say we got that 65-foot piece of wire, right? So it's a half wave at 40 meters. You can also get it to resonate at 20 meters. You can also get it to resonate at 15 meters. You can also get it to resonate at 10 meters. And the big draw to these kinds of antennas is that they are multi-band.
And when you go down a band, so if I have the 65-foot, if I go down a band, does it have the same unpredictability when I leave the 40-meter band as fixing up an end-fan half wave, or is it because it's in multiple, it's all going to be predictable?
If you're using the fundamental, I think it will always pretty much radiate like a half wave.
Okay.
Yeah. And to be clear on that, the radiation pattern comes off the broad side of the antenna. When we're talking about these kinds of antennas, there are other kinds of antennas that are called traveling wave antennas, like a beverage, which we won't get into here, where the radiation pattern is along the length of the wire. So you would point the tip of the wire at the station you want to receive, but that's not what we're talking about here. We're talking about the half wave resonance, and those all radiate on the broad side, and then they have nulls out the tips of the wire.
So do we need it to be horizontal? Do we need the ends to point east-west, north-south? Does it matter? I mean, once it's horizontal, does it matter at all which way the orientation is? So,
it doesn't need to be horizontal. You can do vertical antennas, but you were making it sound like you didn't want a 65-foot tall piece of wire in your yard.
I'm not putting a pole up. Yeah. No.
Yeah. And actually, that one would only be a quarter wave if you did a vertical. So it would only be 32 feet long.
That's still too high.
That's still too high. Okay. So we are talking about horizontal antennas here. And if we're talking about a horizontal antenna, then ideally, and again, this is where you can predict how it's going to work, it would be straight, it would be high in the air, and you would point the broadside of the wire in the direction you want your signals to go. That is the ideal situation. Having said that, stick the wire up anywhere you can get it up, it'll work. Like if it's not perfectly straight, if it bends halfway through, or like if you've got like weird curves, or you have to kind of turn the corner around the fence line because your yard isn't quite 65 feet long, it's only 50 feet long, so you've got 15 feet that's kind of made a right turn and gone on. That's fine. Put it up. It'll work. Again, you're going to have these weird radiation patterns that you won't necessarily be able to predict, but it's going to work. And you will be able to hear somebody and somebody will be able to hear you. And when the conditions are right, that might even be your dad in Connecticut.
Okay. So dipole sounds like the way to go, even though I was reading all about end-fed halfway. I don't know why I was so excited about those. Probably because I like the
variability. It's kind of cool.
No, it seemed cool that you could just stick up a wire and have lots of magic happen. But maybe I should ignore the magic.
I have end-feds are great when you want the antenna to come in. Like if your shack is at one end of the antenna. Right. And like, your shack is on one side of the house and then your antenna just leaves straight from the shack and goes down or whatever. Because then your feed point is at the end and that's just super convenient to put up. Okay. The other advantage to an end-fed is that they are multi-band. If you do a resonant end-fed where the length is a very specific length, then you can get all harmonics of the base frequency, the fundamental frequency. Looking at all the ham bands, you'll notice that they're harmonics of each other. 3.5 megahertz, 7 megahertz, 14 megahertz, 21 megahertz, 24 megahertz, 28 megahertz, stuff like that. So like they're all multiples of each other, which is kind of nice. It means that our harmonics from bad transmitters only affect ourselves.
Oh, it's very clever. Yes. I didn't know that. Okay.
Yeah, but it also means that if we have an antenna that'll resonate on harmonics, we can use that antenna on multiples of our own bands.
Okay. So antenna aside, assume we get the right antenna of the right length, whether it goes sort of downhill from our house or maybe a drone puts it in a tree.
Mm-hmm. Yeah, sure,
you have an antenna.
Yeah.
What is the minimum viable HF setup?
Okay. So you got the antenna. You're going to need to get coax down to wherever the radio is. I recommend putting what is sometimes called a balun, also known as a common mode current choke, at the feed point of the antenna. If you have a perfect antenna that is perfectly straight in free space with nothing else around it, you don't need a balun.
I live in a forest.
Nobody has that perfect environment. So stick a balun or a common mode current choke at the feed point of the antenna. It'll solve all kinds of problems.
Balun was the dwarf that went to Moria. Is that right?
It was one of the 12. Yeah. I think he was the one with the ear horn who couldn't hear very well.
What's a balun?
A balun stands for balanced.
I want to know what it is.
It was a choke current.
That doesn't help me.
The term balun refers to a balanced to unbalanced converter. All right. So
balanced to unbalanced converter.
Yes.
Like an analog to digital converter takes analog and makes it digital. This takes balanced and makes it unbalanced.
Or vice versa.
It's bidirectional, and in this case, it's going the other direction. Well, it goes the other direction on transmit. And anyway, your coax is unbalanced, right? Because I've got one driven electrical lead
and
with a ground reference around it, right?
Okay.
So that's an unbalanced signal, but your dipole is balanced. I've got two quarter waves sticking out on either side, and they are operating opposite of each other.
Right, and so when the coax attaches to that, it's going to attach to. If you didn't have a balun, you'd be attaching the core to one side of the dipole and the ground to the other.
Correct,
and that's not okay. So
it actually ends up working out okay because they're currents that are relevant here, not voltages. But the problem comes when your antenna is not perfectly symmetric. Now you get unbalanced currents in your antenna.
Okay.
And those unbalanced currents actually come back as common mode on the outside of your coax and wreak merry havoc with things.
Okay. And so a balun does something magical with, I assume, loops of wire and transformers that I don't understand.
Yeah.
To fix all that.
You know what a common mode choke is?
Let's pretend that I don't.
Let's pretend that you don't. Okay. For the benefit of the audience. Absolutely. So balanced currents are currents that are matched, right? I have these, 1 amp going that direction and another amp coming back that direction. That is a balanced current. That is known as differential mode currents. They have the same amount of current going in opposite directions. If you run that through a inductor, then the magnetic fields from those balanced currents will cancel each other out. And it basically makes the inductor completely transparent.
Okay.
Right? And so differential modes currents will pass right through an inductor, assuming you wind it correctly, which is what we're doing here. But a imbalance in those currents, whatever is different between the two different wires going through this inductor, does create a net magnetic field. And that inductor then acts like a let's see here, low-pass filter, because it'll pass DC, but it blocks AC. So yes, it acts like a low-pass filter. And so if you make this inductor big enough, then it just basically blocks all radio frequencies, but only the common mode of those radio frequencies. So it forces the currents going through that device to be differential mode. It looks like a very high impedance to common mode, and a very low impedance to differential modes. And when you have that high impedance to common modes, then it basically says, nuh-uh, I know you're not symmetric out on the antenna, but you cannot reflect that other stuff back down the antenna, or back down the feed line, excuse me.
Cool. I think I kind of understand that.
So in this case, it kind of acts like a protection device.
Okay.
Yeah.
So we've got an antenna, we've got a balun.
You got a balun, you got the feed line that brings it down to your shack. Now, what radio do you connect it to? There are a bajillion and a half answers to this question.
Yeah.
You are looking for what is the simplest that we can do.
But also safe, because there have been some radios lately that are coming out of other countries that this is more the UHF.
Oh.
VHF and UHF, yeah, the Baofangs and
I have one of those.
And they don't.
They're not great.
They litter on the other frequencies.
Yeah, they're not great.
Okay, but so we want one that isn't in the not great category.
Sounds good. Don't
want the FCC showing up here waving their guns around.
No, it's other hams and pickup trucks usually.
Yeah. Okay. What's your budget? Are we talking $100, $1,000, or $10,000?
Let's shoot for $500 all in.
$500 or less. Okay. So so we're looking at either like a used HF radio, and if you get anything from, I'm just going to make a broad generalization. Anything from Kenwood, Yaesu, or ICOM is going to be fine. Like, you're not going to get the FCC knocking down your door, assuming the thing is functioning. And if it comes from any of the one of the big manufacturers, it's going to be fine from a FCC knocking on your door standpoint. So a used radio is a very good option because, shock and horror, Morse code hasn't changed in the last 100 years, right?
And yet I still can't learn it.
And you're a musician, man. Come on. But once we learned how to put out a continuous wave of signal instead of a spark gap, which I think we figured out how to do in the 20s, like CW transmitters haven't changed. By the way, that's what CW means. The term nowadays, CW and Morse code are roughly equivalent. They're roughly synonymous. And a radio will often say it is, you put it into the CW mode.
Right. What
the heck does CW mean? CW means continuous wave. Okay, great. I thought all transmissions were continuous wave. I'm going to ignore single sideband for the time being. CW is a term that differentiated it from spark gap, which was not a continuous wave. Spark gap is noise that you would filter down to try and narrow the amount of bandwidth that it took up. Anyway, but like any radio from the last 100 years that can do CW will work just fine today. To be able to talk CW to anybody else. So any used radio from the last 20 or 30 years is basically anything that's solid state. Unless you want to get into doing tube radios, okay, then stick with solid state, and anything from the last 20 or 30 years is going to be a fine radio. You won't have any problems with that. If you want something new, there are lots of different options. Do you want a kit something that you assemble and learn a little bit about the radio as you go and say, hey, I built this. This is pretty cool.
So I can do a kit. I built the QRP Labs, what was it called? Something 3.
The Ultimate 3.
Yeah, the Ultimate 3, and I built a bunch of filter modules for that and played around with that. So I did that. So that was okay. That wasn't a big deal.
Okay, so the Ultimate 3 is the Whisper beacon. I have one of those as well, and those are really cool. Whisper stands for Weak Signal Propagation Reporting. It's a digital mode. We're not going to get into it here. We want to stick to CW.
We have a show about it, so
you do?
Go listen to that show instead.
You want to do CW, and so actually from QRP Labs, the kit I was going to recommend is called the QCX. The QCX is a CW transceiver.
Okay.
I believe they're mono band. So you pick a band, and but they're less than $100.
Oh, so I can just stack them.
Yeah, exactly. They're less than $100, and you make them for
$55.
Yeah,
they're like candy. You can get 10 of those.
Oh, okay. Okay,
it is a wonderful kit.
So, but I see that this is 5 watts. That was another question I had for you surrounding the HF rig thing. Is what power? I have no notion of what power. So I see people with 100-watt radios. I'm like, okay, is that how much you need to get significant distances, or is 5 watts fine?
So 5 watts is what's called QRP. The Q codes are from the old Morse code days, like telegraph days. Q codes are just like short little 3-letter codes that have meanings. They're somewhat arbitrary. You just kind of have to memorize them or look them up. QRP means lower your power output or low power output.
Shut up.
Well, basically what it means is your signal is incredibly strong here. You can transmit on less power if you want to.
And QCX is hello. Hello, is anybody there? Is that right?
CQ.
Yes. So CQ is, you can think of it like seek you.
Yeah.
Is the way that I remember that one. The advantage to CQ is that it makes a very recognizable sound in Morse code. Da 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 da. Like you can pick that out of like a pile of noise and blips and bleeps. If I hear da 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 da, I know exactly what that is and what it means. Yeah.
I still don't. He said it twice, so it's not going to get through to me.
But the QRP, so it's a low power transceiver. There's a huge community around QRP transceivers because it's amazing what you can do with so little power. CW or Morse code puts all that power behind a very narrow range of frequencies. It's one tone, right? So what it's called your power spectral density. The wider your signal is, the more frequency range it uses for the same amount of power, you end up getting less amplitude out of it, right? So you can think of power as kind of the integral of the shape of your signal, right? So like the area underneath the graph. And if you've just got this very narrow spike, then it makes a very strong signal, as opposed to single sideband, which is a human voice, which is about 2.7 kilohertz wide, as opposed to Morse code, which is typically like 10 hertz wide, right?
Sure.
10 or 20 hertz wide. So you have to spread your power out over a larger range of frequencies. And so it ends up having a lower overall amplitude and lower overall effectiveness for the same amount of power. So 5 watts on CW is actually way more powerful than it sounds.
Okay.
Now, if you had a 100-watt transceiver, you're gonna be able to get through a lot of situations that a QRP radio just can't. But part of the fun with QRP is I've got this little tiny battery powered thing I can fit in my pocket, and a spool of wire, 30 gauge wire that's super tiny, that I can, walk to a park, throw up in a tree, and start pounding out contacts with Morse code. And, with this little tiny kit that I built that runs off of, 3 AA's or whatever battery you choose to put in there. And there's just a lot of pride that goes along with what can I do with as little resources as I have. If you want to make sure you can talk to the person and you don't want to have to deal with current conditions, then get a 100-watt transceiver.
Well, I just noticed they have a 50-watt amp you can buy for it. So
they do, yeah.
So that would probably fix that if that was a problem.
Okay, so is 50 watts enough for him to talk to Connecticut?
Almost certainly. And
5 watts would be, you kind of have to try and wake up at 3 a.m. sorts of things.
Probably not 3 a.m.
Well, on 40 meters, 40 meters. So the advantage to 40 meters is that it's open most of the day. Pretty much all the time, 40 meters is open. There are times where it is noisier than others. And there are times where there are other bands that are going to be better than 40 meters, but it's pretty much always open to somewhere. The higher the frequency, the more susceptible to ionospheric change you are. There's what's called the maximum usable frequency, and it kind of moves up and down. Above that frequency, and the band's just closed. It doesn't refract anywhere. And below that frequency, your signal is bouncing around.
Which is how you can get to incredibly strange places, because it not only would jump from California to Connecticut, it may take a path that hits Kansas and then back up and then down to Connecticut and then back up and off to France or wherever.
That's called multi-skip. Yeah. Multi-skip is definitely a thing. And over here on the West Coast, going across the Pacific is incredibly common. You will hear stations from New Zealand and Australia and Japan and China and just like all of Eastern Asia. Is just wide open to us because there's nothing between here and there except very reflective water and very refractive ionosphere.
All right. I like this idea. And has a GPS interface like the other thing. Oh, so this can do whisper as well.
It can do whisper, yeah. It will not do voice. It is...
I don't like talking to people anyway. Present company accepted.
Says the people who have their own podcast.
I'm talking at people.
Yeah, that's true. Yeah. Makes perfect sense.
So I've got this, the antenna. I assume I got a key somewhere. I'll figure that out. Yep. And do I need an SWR meter?
So an SWR meter is something that you need when you set up your antenna and if you ever think your antenna is broken. You don't need the SWR meter in line every time you operate.
And this is a thing that you put in between your antenna and the transceiver, and it tells you if there's lots of bad juju coming, bad stuff coming back down the antenna into your transceiver.
But isn't that why you have the Balun thing?
The Balun, yeah. So the Baluns will help protect against this. The SWR meter is just kind of verifying that everything is doing the right thing. And the Balun at the antenna won't protect you against a failure in your coax. If your coax is broken, the Balun at the antenna is not going to do anything to protect you against that. Okay. That will send all your energy right back at your transmitter, and bad things happen. So the SWR meter, its standing wave ratio, it measures the amount of power going out versus the amount of power coming back. In an ideal situation, 0 comes back and it all gets radiated. You'll never be perfectly ideal. So like the ideal situation is called a 1-to-1 ratio, where I don't ask me to explain what the ratio is because it's weird. Anyway, 1-to-1 means that you have 0 energy coming back from the antenna. Typically, 2-to-1 is considered totally safe and acceptable. You can kind of get away up to 3-to-1 most of the time, but anything above 3-to-1 and you want to stop transmitting and figure out what's going on.
Okay, have I lost you and I should ask him other things?
Well, I'm looking at the order form now. There's a lot of options here I got to think about. Like, do I need this dummy load thing and this TCXO? So, what the hell is that,
You do not need a TCXO. Do you know what a temperature controlled oscillator?
Oh, yeah, okay. I know.
You don't care how stable your frequency is. For what you're doing, you don't need a TCXO.
Okay.
It's not stable anyway. It doesn't matter. It might help you get to your dad.
Yeah.
Who knows?
Dummy loads will help while you're building things because it means you can transmit into a known good load while you're testing your transmitter.
I can't just put the wires into a bucket of sand?
Unless you know it's exactly a 50 ohm non-reactive bucket of sand, probably not.
All right.
Yeah.
How do you get the resistance of the beach?
There are ways of measuring the impedance of ground. It can be done.
Okay, while Christopher fills out that form and will interrupt us and gets additional information about the acronyms, mm-hmm. I too have an amateur radio license.
Oh, nice.
I mean, the test wasn't that hard.
Nope.
And
not.
if you study for it, and then you go in and you take it right away, it's just totally easy. Because I memorize things well. But anyway, that doesn't help at all. I mean, I can pass the test. I probably could pass the general test if I studied more for it, mm-hmm. because it's just physics and math and I can do those things.
Yeah.
But this process of setting everything up mm-hmm. and figuring out how to put it together, I mean, I can say which bands I'm allowed on and I know how to translate frequency to meters, except for the speed of light. But there's so much more. And I'm not super comfortable hanging out with the ham clubs because
Yep.
I'm weirdly, as I get older, I'm still younger than all of them put together. Well, no, all of them. And there's a certain gender problem and a certain homogeneity to many ham clubs. And I can only take so much mansplaining in a year. And they usually
she gets to that in a month from me, so.
No, but the ham radio clubs, it is kind of like I get a year's worth in an hour.
I remember having that happen to me when I took the exam sometimes.
Right.
I'm just here for the exam. Please stop talking to me.
Yeah.
Yes, you are absolutely correct. I'm going to pull the typical cishet straight white dude answer and say not all ham clubs, but many ham clubs. And certainly a lot of the vocal ones. It seems like a lot of the ones that are trying to do the outreach are the ones who I don't know how to word this. They haven't figured out how to do it correctly. The communities in the ham radio larger community that are looking at the demographics of the ham and saying, wow, we're getting old and we're dying off and we need to get more young people into the hobby. Why is that so hard these days? Well, because before the 90s, ham radio was actually a practical hobby. You could use it to talk to your friends across town or across the world. You could use it to meet people from the other side of the world and talk about things that you kind of had a built-in common hobby, amateur radio. And it was a way of communicating for free that wasn't otherwise available to us with super expensive long distance. And when your TV and radio stations were only, the local broadcast, and maybe you were lucky to have your national television network, but you didn't really get news from the rest of the world. And so radio was the way that people communicated long distances with people other than people that were within walking or driving distance from them.
So the internet killed the amateur radio star?
The internet killed amateur radio as a practical hobby. Internet and free long distance, which is kind of both happened at the same time, right?
Well, I remember when we first had licenses, we used to talk when you were on the way home from Palo Alto. We'd talk over 2 meter and, do the stuff we would normally have done on a cell phone.
Exactly. And
but
nowadays,
also, when I went to the emergency response team training in my community, the fact that I had a ham license was really exciting to them.
A CERT training? Is that what you did?
A CERT.
Yeah, CERT. It was a community emergency response training, I think is what it stands for.
Team, I think is what the T is for.
Team. Okay.
Does that matter anymore? I mean, does anybody use amateur radio for disaster situations anymore?
So the short answer is yes, they do. I have very unpopular opinions about this within the ham community. Go ahead and rev up your email programs now, mark@halibut.com, just go ahead and hit Control N and start writing your response to me, telling me how wrong I am right now.
You could have just left that out, and it would all come to us, and we would have filtered it for you.
No, I don't want to put you guys through this. I am personally of the opinion that hams in emergency response situations are not as useful as we were even about 2 decades ago, a decade to 2 decades ago. We used to be incredibly useful for local situations like earthquakes or floods or power outages or anything like that, where conventional communications went down. Telephone lines are incredibly reliable until they're not. And when they're not reliable, but the police and Red Cross and fire, police and fire, they have their own radio systems, but the Red Cross doesn't. And all of these radio systems don't necessarily intercommunicate with each other. But things like 9/11, things like Hurricane Katrina, these have kind of given city and state and even cell company groups a wake-up call, and they said, all right, we need better communications. We can't suffer these kinds of problems anymore. This is getting more and more common. We need to actually invest the money in reliable communications. And cellular companies are doing the same, right? It's now no longer the case that like the cell towers just fall over, not physically fall over, but like electrically fall over. They just stop working whenever there's a power outage or where there's an earthquake or whatever it is, right?
Yours may not.
In San Luis Obispo, they don't. And the phone companies are very reliable now. And so these kinds of communications used to go out all the time.
Yeah.
And they would call in hams to provide backup communications. And I think the conventional communications have gotten a lot better, which means that the bar of how bad a disaster has to be for where hams can provide a service has risen. Right? That bar has risen. The recent example I give of this is the Puerto Rico hurricane several years ago, right? Like the entire island of Puerto Rico lost power and lost communications. And I mean, it was just a complete disaster. And the ARRL sent down 50 hams with a bunch of equipment and said, all right, let's go rebuild communications on the island and get them back up and running. And by some accounts, the hams that were sent were completely, or at least some of them, were completely unprepared for what they ran into. And it's not just a training issue. It's the attitude of, I'm a ham, I'm the only option, everything else is completely broken. You have to go through me, right? As opposed to, I am here to help. Please tell me what you need and I will see if I can provide it. Right. And so it was kind of this attitude of that left over from the 80s and 90s where that actually was the case. The hams were the only ones there that were providing communications. And like that was true, but it's not true anymore. And we need to get rid of that attitude. So do I think ham radio is useless in this regard? No. But I do think the bar has been raised to the point where we get called in is a much worse situation. And so we need to up our game if we want to still be useful in those kinds of situations. Alternatively, we are still very useful in the smaller scope situations. I still think hams are very useful in a CERT type environment. My local community, right? Like police and fire and Red Cross may still have communications, but if my local neighborhood has a power outage, right, and we still want to be able to talk to our neighbors, either hams or GMRS or FRS or something like that, some sort of a radio communication group is still usable in that situation. And I think really that's what we need to be concentrating on if we're interested in emergency communications. Having said that, I personally am not an emergency communications guy. I know lots of people are. I still participate in my Aries check-in nets here in the South County, San Luis Obispo. I even run the net once out of every 5 weeks, but I'm not one of the guys that fetishizes emergency communications for ham radio use, or ham radio use for emergency communications.
Okay, let's drop that topic. I understand where you're coming from, and
okay,
I don't know, it sounds reasonable to me. But
again, mark@halibut.com. Send all your hate mail straight to me.
Going back to the clubs and not necessarily wanting to interact with humans in real time.
Yes.
Are there groups or forums for folks who are interested in the digital modes or the tinkering?
Oh, yeah. Yes. I don't know that it's going to be your conventional ham radio club. There definitely are conventional ham radio clubs that are less bad than others. I would look for college clubs. I don't know whether UC Santa Cruz has a ham radio club, but
they do.
They do? Okay. That is probably a good club to go to because they're going to be younger student age people there, and you'll be the old person in the room. It's kind of refreshing from a ham radio club perspective.
She's making quite an amusing face right now. I don't think she...
What about online?
Online is also another good option. There are lots. Oh, it's like, I don't want to show up in person. What are you thinking? Yeah, there are definitely a lot of online clubs. Right before lockdown, I started a club here in the San Luis Obispo area called CQ805. And my goal was to just kind of make an online community. It ended up being a Slack workspace for hams in the area to get together and chat, and then we would get together at lunch. Like, it was kind of meant to be ham radio clubs for the working stiff, as opposed to the retired folks who always met for like breakfast on Tuesday mornings at 10 a.m.
Yes.
Like, I can't do that. I'm working. Right. Or, the Aries meetings at 8:30 p.m. at the county comm center across town. It's like, yeah, I got my kid at home. I got to go spend time with her. Those kinds of things. And so, like, the time that I had to go out and be social was lunch hours. And so I tried to start that in the local area. If there's any listeners from San Luis Obispo, CQ805.radio. And honestly, you don't even have to be a local to San Luis. If you're just a ham and are looking for a community online, go check out CQ805.radio. Yes, and that has, since the lockdown happened, that has become pretty much entirely an online community. We will occasionally get together for like a field day event. There are a lot of people there that are coordinating kind of the local Arden network, ARDENE, RDE. No, it's pronounced Arden, but I think it's spelled differently. Anyway, like IP over ham radio stuff. And so it's pretty active with that. Yeah. There are communities. I wouldn't be able to tell you which one would be best for you. There are a lot of active communication or channels on Reddit. I don't know which ones are good because I don't frequent them a lot.
Okay, what about SDR? That's something I hear a lot. The software defined radio?
Software defined radio, exactly that. So, okay.
He's like, this is a whole nother podcast.
Not even in the outline.
It really is. Yeah, I warned you guys.
We haven't even gotten to satellite yet.
We haven't even gotten to satellites yet. Yeah. SDR stands for software defined radio. Basically, think of it as like an analog to digital converter that is sampling the RF spectrum directly. And there are various different levels between like a hardware radio, where you've got RF on one side and audio out the other side, demodulated audio out the other side. And then what's called direct sampling RF, which is kind of the opposite end of the spectrum, where it's an antenna into an ADC. And then the ADC is literally sampling the radio spectrum directly and feeds it all into a very high bit digital data stream. And you do everything in SDR
Software.
Digital software.
Yeah.
Silicon. Digital.
What is it's like a special type of DSP. Great gravy. Why did that take me so long? You do everything in digital signal processing.
That question came from Fred, who was interested in entry-level options and licensing requirements. And I don't want to go too far into that.
Yep.
But it sounds like the QRP Labs might be a good place for kits for various things if you're in an entry level and want to just check out what's happening. And you can listen without getting licensed.
Correct. So the QRP Labs is very hardware defined. He likes building things down at the individual component level. SDRs, if you want to get started with listening using an SDR, I would check out rtl-str.com, and they make what's called the RTL dongle. It is USB on one side and an antenna port on the other. I think they're about $25 or $30. And if you get the ones from rtl-str.com, they actually will receive the HF spectrum as well as the VHF and UHF spectrums. They do something that enables the reception of HF that a lot of other RTL SDRs do not, or RTL-based SDR receivers do not. So if you specifically want to receive HF bands, look for the rtl-str.com brand SDR receiver. And they're very inexpensive, but they work reasonably well. They're not going to be the best ones on the market, but if you're just looking for something to get started and be able to tune around and listen, they're great. They do not transmit.
And we talked a little bit about licensing. Technician is the lowest level, and it's a little bit of math and science and physics, but it's also
electronics.
Electronics has a lot of practice examples out there on the internet, some of which you have to pay for, but many of which you don't. And so,
don't ever pay for anything because you can get them for free. All the tests for the ham, or at least in the US, every test question you will ever get on a ham radio exam is known ahead of time. There is a pool of several hundred questions from which 35 will be chosen for your exam. You don't know which question you're going to get, but every question you get is known ahead of time, including the answers. And so you can study all the questions and answers ahead of time. And there are websites out there that will, for free, generate a random practice exam. So I wouldn't ever pay for anything like that because for the exam itself, it's too easy to script and the data is all public. There's no reason to have to pay for that.
And some of the questions have the same methodology to answer them, like converting from meter band to frequency. Yeah. And so some of these practice ones will tell you, well, this is the piece you need to know. And so if you want to pass the test, I'm confident that those of you listening still having gotten this far in this show can easily get it done.
Yeah.
Okay. But you have a company, which we were supposed to talk about, halibut.com or electronics.halibut.com.
Correct.
And when you drove by and we hung out for a little while, we saw this satellite optimized amateur radio SOAR thing that was very cool. But you've put a pause on that, and now headsets?
So, SOAR is a... if there are hams who are listening, it's an appliance for operating FM satellites. Because building a station for doing satellites can be a bit of a chore. It's totally doable, but SOAR just kind of does a lot of the hard work for you. It does the audio, it does the frequency shifting automatically for Doppler, it does all the calculations for that, and records the audio pass, and it does it's a full duplex radio, transmits and on one band and receives on the other at the same time. So it's just an appliance for operating FM satellites. I ran into a problem with the output of the UHF transmitter not being stable when put into a bandpass filter, and I can't do it without filtering, and I can't make the transmitter not oscillate when it is filtered. And I've paid professional RF engineers to come look at this with me, and they're like, I can't tell what's going on. The transmitter module you're using is doing weird things. So I've put that on hold for a bit while I work on another project that's actually going to bring in an income, because I'm living off of savings for the last year and change. So what I'm working on now is what's called Open Headset Interconnect Standard. It is a published standard for the interface between the radio and the user. In Ham Radio, we have standards for things like DC power. Like every radio, all the commercial radios you get are going to be powered by 13.8 volts plus or minus 15%, right? A normal quote-unquote 12-volt supply. And they may have various different connectors, but it's easy to convert from one connector to another because it's the same electrical standard. Similarly, on the RF side, we've standardized on kind of 50-ohm coax. And the coax may have different connectors, but because it's all the same electrical standard, it's easy to convert from PL259 to BNC or whatever, because it's the same electrical standard. We don't have that same kind of standard between the radio and the user. There are so many different types of microphones. Is it an electric mic or a dynamic mic or a carbon mic, or is it a line level input? Is it speaker level output, or is it headphone level output or line level output? If it's speaker level, is it ground referenced or is it push pull? Like there's just no standardization. And I haven't even gotten into physical connectors. There are so many different types of physical connectors. And then even when the connector is the same, the pinout is different. It's maddening. And so if I come into an environment where I've got my headset that I've spent good money on, several $100s on a really good headset with headphones and a microphone, and it's got its connector on it, or series of connectors, and I want to plug it into your radio, I need to have the very specific adapter that goes from that headset to that radio. And it may be different than the headset that you have. And I don't want to put your headset on my head because it's got your ear goobers in it. And I don't want you using my headset because I don't want your ear goobers in my headset, right? And ear goobers is going to end up in the glossary of this document. I know it. But as an explanation of why we don't want to share headsets. But you end up with this full mesh of adapters between every single different type of headset and every single radio. And in your own personal home shack, that's not that big of a deal because you've got a relatively static and small number of devices. But if you go into a multi-user environment, like a club shack, where you've got, 50 club members and they may have, 10 different styles of headset, and you've got 4 or 5 different radios in the club shack, that ends up being a lot of different adapters. Or an EOC where you don't know what radio you're going to be assigned to. EOC is an emergency operations center. Again, back to the emergency communications thing. You don't know what radio you're going to be assigned, but I definitely want to use my headset on whatever radio it is that I sit down at. So I've designed this standard interface in the middle, and we make adapters on both sides of this standard in the middle. So I make one adapter that goes to this particular radio, and it adapts whatever the interface on the radio is to the OHIS socket. And the OHIS is the standard. And then I make a second adapter that goes to my headset that converts whatever my headset is to the OHIS standard. And that adapter on my headset stays with my headset, and I never disconnect it and give it to somebody else. And that adapter on that radio stays with that radio, and you never have to disconnect it because somebody else brought their headset in. And now that I have this standard interface in the middle, I can connect my headset with my OHIS adapter to any radio that also has its OHIS adapter. And it allows complete interoperability from headset, from any headset to any radio.
Okay, that makes sense. Why hasn't somebody done it before?
I don't know.
Cool.
But I've heard a lot of people come to me and say, "Oh my gosh, we have this problem all over the place. I very much want this." So right now I've written the standard, although it's still kind of a work in progress. The standard itself is open. So that the definition of that middle layer is a completely open standard. I don't want to own licensing on it or anything like that. I want everybody to use it. The devices that actually implement that standard, so the adapters on either side or anything that's in the middle, those can be proprietary to the companies that make them. So, for example, Halibut Electronics I'm working on radio side adapters and user side adapters, the headset side adapters that I just looked earlier. I got prototypes that have made it into the United States. They just left LA this morning from the assembly house in China. So I should be getting them early next week to continue developing that. And I am hoping that I will be able to click the button and say, manufacture 100 of these for me and send them to me, and I'll start selling them. Yeah.
Cool.
But the devices themselves are proprietary, but the interface that they use is open, and anybody can make devices for it.
I hope that takes off.
Me too.
Standardization really is very useful, especially if you can agree upon only one or two standards.
Yeah, I'm okay with multiple physical standards because it's easy enough to build an adapter if it's just wires. It's when they're different electrical standards that's a real pain in the butt.
Okay, I have a couple more questions for you. I know we're way over time.
Way over time.
You have a podcast that you are on frequently. It's called Ham Radio Workbench.
Correct.
What's it about? Who is it? Who is its intended audience? And how big of a lawn do you need to mow for the average Ham Radio Workbench podcast episode?
Yes. So, Ham Radio Workbench is a technical deep dive into topics of interest to the amateur radio, is the podcast opening line that George usually says.
Wait, does he stop there? To the amateur radio?
To the radio amateur.
Okay. Because I just have this idea of little radios listening to you.
Well,
yes.
I mean,
I would be okay with that.
Yeah. Okay.
Did I say amateur radio? Yeah, I meant to say radio amateur.
That's sorry. I shouldn't have hassled you.
We're going to roll back the tapes. Anyway, we talk about all kinds of technical topics, from like what kinds of tools to use to 3D printing, circuit analysis, circuit design. A lot of times it's typically kind of chopped up into two different pieces. The first one is the what's on your workbench, where we kind of go roundtable around all of the hosts of the show, and we talk about the things that we've been working on. And it's just kind of a very casual, tends to be very long, even though when we say, okay, we got to get through this quickly, hour and a half later, here we are talking about what's on our workbench. But it's a lot of, just like, what kind of cool things have we seen lately? What are we working on? Yada, yada, yada. And then the second half, we usually have some topic that we're talking about. Like recently, we recorded an episode on what does it take to build a repeater? What are all the different parts that go into building a repeater? I did an episode on OHIS. We have done episodes on PODA, Parks on the Air, which is a program to encourage people to, get their portable radio, hike out to a park somewhere, set up an antenna, operate a bunch, talk to other people, and then pack up and go home. And you end up getting points for the more contacts you make, and it's kind of gamified ham radio and stuff like that. So we've done topics on 3D printing, technical topics of interest to the radio amateur. It's intentionally very vague.
Cool. I mean, ours is sort of about engineering and people, and sometimes we have sci-fi authors. So,
nice.
It really is not focused. Well, it's focused on people I want to talk to. So
exactly,
since I'm in charge of scheduling,
it's just an excuse for me to get people on the show.
It's just an excuse for me to chat with people, ask them questions that if I asked them just normally, they would be like, "Why are you so weird? Why do you need to ask me these detailed questions?"
And then Mischief asks, "How big of a lawn do you need to mow for the average Ham Radio Workbench podcast episode?" Our show goes long, like 2 hours is considered a short show for us. We've been known to do 3.5 hours at times.
I can't sit down that long.
Neither can we. We take breaks and do potty stops in the middle and whatnot. And the joke is always that our listeners come back to us and keep saying, "No, keep it long. We like it. I've got a huge lawn I need to mow, and I put your podcast on while I'm mowing the lawn." And so the joke has become that we measure the length of our show in acres of lawn. And it's typically about an acre of lawn per hour.
Ours is, I think, is usually measured in baskets of laundry.
Ooh, that's a good one. Yeah. Yeah.
All right, Mark. I think that we are going to close up our show now-ish. Do you have any thoughts you'd like to leave us with?
Just the same thing that I end all of my podcasts with, which is be good humans. There's not enough of that out there these days. And we all try, and I know we do, and that's good. But keep trying and keep encouraging others to do so, and, keep making a difference in the world.
Our guest has been Mark Smith, N6MTS, known as SmittyHalibut on most social media, including YouTube, Mastodon, and GitHub. You can find his products on electronics.halibut.com, and he is the host of Ham Radio Workbench, if you want to hear more from him.
Thanks, Mark.
Thank you.
I think I have learned things that I needed to learn, and you've explained some things that I never understood very well in ways that I now understand them. So thank you.
You're very welcome. I'm glad to be here. Thank you all for inviting me.
Thank you to Christopher for producing and co-hosting. Thank you to our Slack group, our Patreon listener Slack group, for their questions. And of course, thank you for listening. You can always contact us at show@embedded.fm or at the contact link on Embedded FM. And I don't have a quote to leave you with this week. I think Mark's "Be Good Humans" is probably a good place to leave it.